In this video, I will talk about a very nice tool called Fritzing for drawing schematics of the circuit diagrams, something that you will need to do for your homework as well as for your final robot design project. So you'll start by going to fritzing.org. So that's the URL. Open your browser and go over there, click on the download button, and then you can click on no donation or donation and hit the download button, and you can find the software for your operating system, Windows 32-bit, 64-bit, Mac OS X, and so on. I'm using a Windows 64-bit, so I went over here and I downloaded the zip file, and you extract the zip file, and inside the zip file you'll find a single exe file called fritzing.exe. All you have to do is unzip this in a folder, keep it safe in some location, and then you can run that exe file from pretty much anywhere you want. You can even put the contents of the zip file on a USB drive, and you can take that with you wherever you go. So this is a software that doesn't require installation. It's what you call a portable software. Okay, so after you have downloaded it and extract the zip file, you will see the exe file. So let me show you, what the folder looks like. So this is my folder. I put in my download folders and I see the fritzing.exe over here. When you launch this program by double clicking on this, the window opens up and you see something like this. This is a welcome tab. Here is a breadboard tab, schematic tab, PCB, and code. The tab where you spend most of your time is the breadboard tab. So you will start by clicking on this. And what you will see is basically a default breadboard. This is the prototyping board that you'll be using for making our circuits. Okay, so first thing we'll do is we'll make our breadboard to be smaller to match with the one that you have in your kit. So as soon as I select this, on the right hand side you see in the inspector window the size of it, that's foot plus. We will choose it to be a half plus one. This is the breadboard that you have in your kit. Okay, so this is what we'll be working with. Now breadboard is a very nice platform for making connections. Instead of making connections of the wires and then taping them together, what we can do is we can insert the wires in the holes in the breadboard. So first thing you need to do is understand basically how these holes are laid out. Okay, so you will notice that on the top, if you lay it like this, on the top there's a blue line running. Okay, and next to that blue line you have all these holes, and basically underneath this breadboard, if you were able to open it up, you will see that all of these holes are actually connected together. So when I click on any of these holes, you see all these holes in the same row light up with a yellow color, and that's an indication that all of these are connected with one another. So if I make a wire connection over here and I make a wire connection over here, even though physically they may look like they're not connected, but there is an internal connection between all of them. Similarly, all these rows of holes are also connected that are close to or next to this red line over here. Okay, but there's no connection between this row of holes and this row of holes. Okay, now typically we will use these two rows of holes for putting the power here. So let's say, for example, 9-volt battery, the positive terminal connected with a red wire might connect over here, and essentially now we'll be able to tap into any of these holes to get a 9-volt connection. Then similarly, the black wire of the 9-volt battery would go here, the COM wire or the ground wire, whatever you may want to call it, and they'll be all connected and they'll be at ground voltage. Okay, and we'll pretty soon see how we can do those kinds of connection. Then if you come down, you see that there is a separator over here, and above the separator there are 5 holes of columns. So we'll call this one column, and they're numbered. So this is 1, 2, 3, 4, 5, up to 30 columns. So you have 30 columns, and then you have F, G, H, I, J. These are the row numbers over here. Similarly, over here you have 30 columns, and then you have columns from rows from A to E. Okay, so what happens over here is that all these holes in one column, each individual column, are connected together. So all of these are connected, all of these are connected, all of these are connected, but there's no connection between this and this. Okay, there's no connection between the two columns. And same with the situation over here. These 5 are connected, but there's no connection between these 5 and these 5. Okay, so that allows you to sort of create a circuit, using this section of the breadboard and another one to use this part of the breadboard. Now continuing downward, you see again that we have a series of holes which are all connected together next to the blue bar, and then again another series of holes that are connected together next to the red bar. Okay, so let's try to put together a very simple circuit using Fritzing. Okay, so what we will do is we'll put together the circuit that we made when we were discussing the light emitting diodes. Okay, so light emitting diode, and over here we had a 9-volt source. We had a LED, okay, which had a forward voltage of 2 volts, and we had a resistor that we picked to be 330 ohm, right? That's what we did. So let's try to put this circuit together using Fritzing. So first thing we'll do is we will get a 9-volt battery. So on the right hand side, you see I have all these parts. So we have the core. You see these are the core parts over here. You can see there is a resistor, there is a capacitor, there's a tantalum capacitor, electrolytic capacitor. Then we have a diode, we have a transistor going down. This is a photocell. So all kinds of common elements are present over here that we will use. This is where you can create your own library of parts. These are all related to Arduino microcontroller and so on. So we'll discuss some of these later on. Let's focus on the core. And what I'll do is I'll start by searching. This is what I find the easiest to do, searching for battery. Okay, so I'll do a search for battery, and hopefully I'll find a 9-volt battery somewhere here. Let's see. Do I have a 9-volt battery? So this is the LiPo battery. This is also a LiPo battery. That's a 9-volt battery. So what I do is I basically click on it and then I drag it over here. Okay, so I click and drag. Now I see I have 2 wires over here. So the red wire, that's, let's say, positive, and I will connect it to the red hole. So I basically click here and then I drag and drop over here, and as soon as I click here, you can see that all of these are connected. So which means that all of these holes are now at 9 volts, and this one I will connect to the ground bar, so that all these holes will be at ground. So now basically this particular row becomes the power row, okay, and this particular row becomes the ground row. So all these holes over here, anything you connect to one of these holes will be at ground voltage, or we'll call it 0 volt, and all of these would be at 9 volt. Okay, all right, now let's get a resistor. So we can go on the core and we can see the resistor. I can drag and drop it over here. So let's put it across in these holes, okay, over here. Okay, now we want to make sure this is 330 ohm resistor. So I'll select this and I go here and I can select it to be 330 ohm. I find that, so that's 330 ohm. And notice how the color bands change over here, right? You see this becomes orange, this is brown, so this is 3, and that's the multiplier is 10 ohm, so we get 330 ohm. And let's not care about the tolerance band over here. Okay, now we have to make the connections. So we know that all of these points are connected together. So I'm going to basically draw a wire from here. I'll click on this hole and drag and bring it over here. And I'll basically change the color of this wire to red because I know that's coming from the power. So when I do this, basically I have connected these holes, right? And then this hole is connected with this one. So essentially these two are connected together now, right? So I got my 9 volt power supply connected to the one end of the resistor. And now I have to bring in my LED and put it in the series with the resistor. So I'll bring it over here. Let's put it right over here. Okay. Let me move this resistor down a little bit so you can see it very clearly. Now you can see that this is the positive side, right? That's a long leg, and that's how it should be. The positive side should be connected here, and we have got our the negative side of the LED, right? That leg is over here. That's the cathode, and this is the anode. And if you hover over it, you can see it says this is anode and this is cathode, right? And now what we'll do is we'll complete the connection. We have to go back to the ground, so we'll pick any of these holes because they're all connected together, and go to the ground row. Okay, so ground row, and you see how they are all connected. And I'll change the color of this one to black because I know that's connected to the ground. So this is basically the circuit that we have created in the schematic that follows from this circuit over here. So we have the resistor, we have the LED, that is resistor and LED are connected together, and then the circuit is completed. And that's the circuit that we have for the LED. Now, unfortunately, this is not a simulation software, so you can't really simulate the turning on of the LED by making this connection. Autodesk has an online software called Circuits at circuits.io, where you can actually do the simulation as well. It's a pretty fun tool, which I'll introduce a little bit later. Okay, so that's the schematic. Now, the advantage of making this a schematic in Fritzing is that you could design your circuit, you could draw it over here, and then you give it to your teammate when you're working on your project and say, hey, listen, this is the circuit, can you check this, and just put it together. Because it looks exactly like the kind of circuit that you would put together using the real breadboard, real LED, real resistors and batteries. You can basically just duplicate it in reality. Okay, so this is the circuit that we have put together. using Fritzing, and this circuit corresponds to what we have drawn over here, right? Now let's say I want to change this circuit and I want to introduce a switch in here. So how would the circuit change then? So I have my 330 ohm resistor, I've got my LED, and now I'm going to introduce a switch over here. Okay, so I've got my 9-volt battery here, it's connected to the ground, right? So I've got my switch over here. So when the switch is open, no current can flow through it. When the switch is closed, when it gets into this position, then the current can flow through it, right? So all I have to do now is basically, move this wire from here. So I'm going to move this wire. Let me delete this, and I'll bring a switch over here. So let's find a switch. So scroll down, and if we can't find it readily, the easiest thing to do would be to basically do a search for switch. But here it is, the push button switch, right? What we call momentary switch. So I'll bring it over here and I'll connect it in series with the LED. Okay, so you notice this, we have the LED over here. Right after the LED, we have the switch connected. So in the same wire, in the same row column of the hose where the short leg is, the cathode is, I push basically my one end of the switch, and the other end is over here. And you can see how the switch is staggering between these two columns of the hose. So I could actually connect something in this side as well to control that part of the circuit, but that's not important over here. Now I got this end, so this end over here, which is shown in yellow, is basically this end, right? So I have to connect it to the ground to complete the circuit. So I'll take one wire and pick any of these holes and connect it to the ground over here. Okay, now as soon as I do that, my circuit is completed. So I have my battery, I have my resistor, I have my LED, and now I've got my switch as well, and now the circuit is completed. So if I want to introduce any other element, let's say I want to introduce a photocell in this circuit, right? So let's say I wanted to get rid of my switch. I select it and I press the delete, and over here in my circuit, I'll replace this switch with a photocell. Okay, so photocell basically acts as a variable resistor. Okay, so it acts as a variable resistor. That's a photocell. So photocell basically acts like a variable resistor, because when more light falls on it, its resistance goes down. When less light falls on it, then its resistance goes up. So where is the photocell over here? So let's look for the photocell. Let me do a search for photo. Okay, I find a photocell. That's a photocell. So I'll bring it over here and I'll connect it here. So let me delete this wire for a second. And of course, this leg has to be here. So this is connected, right? You can see that it's connected. And then I'll connect a black wire to the ground, right? And I can click on this to make sure that they're all connected. I can click at this point to make sure that they're all connected. And these are the circuits that you'll be putting together yourself.